Alright, today I will talk about the problem, the Tamworth Two. In this problem, this is an introduction to graph search, and it gives you this 10 by 10 grid. So what we want to do is we'll just simulate each move by the farmer and the cow, and we will use recursion to see where they will end up. So here's the code. After this is the part where I read the input, and I got the coordinate of the farmer and the cow at the beginning. So if this input is F, then we know where the farmer is, and if it's C, we know where the cow is. And then I just replaced it with a dot, meaning that it's an empty space, because we want to be able to traverse over this place afterwards. So after this, it will use the search method to find the amount of move that we take. So here I created these variables. This variable is the grid that we just received the input from, and then these fi and fj. This is the coordinate of our farmer. So fi is basically the same as the y coordinate of the farmer, and j is the same thing as the x coordinate. And then this is the coordinate of the cow, and this is the coordinate of the cow, and these two are the directions of each. So fdir is the direction of the farmer, and I wrote this here to show you what each of the number represent. So there will be 4 numbers in total, 0 representing the north direction, 1 representing the east direction, 2 representing the south direction, and 3 representing the west direction. So we know that they both start off as facing the northward direction, so I set these to 0 first. And I also created this visited array. We will keep track of what is visited. So this first 10 here, it is the I index of our farmer. This second 10 here is the J index of our farmer. This one here is the I index of our cow. And this one is the J index of our cow. And then this is the farmer's direction, and this is the cow's direction. So what this does is that it will keep track of the positions that we visited. So if we visited this position again, then we will know that this is going to go on forever. So in this search method, I first received this M representing for how much minutes has already passed by. And first it checks if fi is equal to ci and if fj is equal to cj. So if these are equal, this means that the cow and the farmer are on the same square. So that means the chase has ended. So we just return the amount of minutes that we found. And if, this is the part where I check if it's visited or not. So I put in all of our variables here, fi, fj, ci, cj, fdir, and cdir. So if we've already visited this position for both of the cow and the farmer, then we'll return 0, meaning that there isn't a way, because now they'll just go back to the previous ones and go on forever. And first, what I did here is I set this to visited, because we know that if it's visited already, then we will stop this. So we know that this isn't visited, so I set it to visited first. And then here it checks for the direction of our farmer. This is the first case. If the farmer is facing north, we need to check if the farmer is at the edge of the grid, or if in front of him is an obstacle. So if it's either of the case, here's if fi is equal to 0, because fi represents the y position, and when we are going north, we subtract the y position. So if it's 0, we know that we cannot subtract it, and we cannot subtract by 1 anymore. So we know that this is on the edge of the grid, and otherwise, if there is still a place on the, if it's not at the edge, but if it's an obstacle at where the farmer is supposed to be, then the farmer will take this turn and turn clockwise 90 degrees. So it turns from the north to the east, so it turns from 0 to 1. And otherwise, if it can still move north, then we will just subtract fi by 1, meaning that he moved up 1 grid. And then it checks if FDR is equal to 1, meaning that if the farmer is facing east, and then we check if it's at the edge of the grid again, because when it's facing east, we will add J. So we check if it's an obstacle. If it's an obstacle, or maybe the farmer is at the edge, then we will turn clockwise again. Now we're the direction is at 2. It changed from 1 to 2. And otherwise, if we have no obstacles, then we'll just move forward. And then this other one checks if the farmer is facing south. So it's also the same thing, but except we just changed the variables a bit. And the final one is checking the case at which the farmer is facing west. So here, if it's facing west, then if it has an obstacle, we will turn clockwise again, but then we will just turn back to north, so this becomes 0 again. And this is the same code for the farmer and the cow. You just need to change the variables here to the ones that the cows so these variables are C representing the cow, and these ones starting with F are representing the farmer. So you just need to model these variables a bit, and then we will check this position. So now we would have already moved the farmer and moved the cow as well. So now we will check the next move using this recursion method. So we will use the search, but with n+1. So we'll go back to the top, but this time with n+1 and new coordinates and directions. So we'll just keep on going until we reach either one of the cases. And yeah, so afterwards, it will return either 0 or actual amount of minutes, and you just need to print that out, and this is the end of this problem.